students. In the previous video, we had seen that what are the different steps which are involved in an image processing system. In this video, we'll be learning about the different components which are involved in an image processing system. So as you can see, these are the different modules that are involved in an image processing system. The first module that we have is a specialized image processing hardware. Now this image processing hardware consists of digitizer and also hardware that performs primitive operations. Now what are these primitive operations? These primitive operations are the operations that are performed by an arithmetic logic unit. So it basically performs all the different types of arithmetic and logical operations in parallel. The next module that we have is a computer. The computer in an image processing system is a general purpose computer, and it can range from personal computer to a supercomputer. But in case of dedicated applications, sometimes specially designed computers are used to achieve a required level of performance. The next module that we have is a software. So it is basically an image processing software. Now a software for image processing consists of specialized modules that performs a specific task. And a well-designed package also includes the capability for the user to write code that is as minimum as it can. So basically, this is why a well-designed package is very useful in an image processing system. The next module that we have is mass storage capability. Now if I talk about mass storage capability, it basically deals with thousands or even millions of images, providing adequate storage in an image processing system. So basically, it is a very big challenge to provide a mass storage for these large number of images. So basically, mass storage capability is important in an image processing system to deal with thousands of images. The next module that we have is image displays. Now if I talk about image displays in use today are mainly color, preferably flat screen TV monitors. Now these monitors are driven by the outputs of image and graphic display cards that are an integral part of the computer system. The next module that we have is a hard copy. The hard copy devices are used for recording images using different kinds of devices like laser printers, film cameras, heat sensitive devices, etc. Film provides the highest possible resolution, but paper is the obvious medium of choice for a written material. On the top of the block diagram, as you can see, we have a network there. So basically, networking is almost a default function in any computer system in use today. So it basically is used for the efficient working of the entire system. So that's all about the different components which are involved in an image processing system. The next topic that we have is an electromagnetic spectrum. So as you can see, in an electromagnetic spectrum, these are the different types of waves which are involved. So what is an electromagnetic spectrum exactly? The electromagnetic spectrum is the complete spectrum or continuum of all different forms of light. An electromagnetic wave consists of electric and magnetic fields which vibrate, thus making different types of waves. So these are the different types of waves which are involved. The first wave that we have is radio wave. So basically, radio waves are low energy waves with long wavelengths. Radio waves mainly include FM, AM, radar and TV waves. These are low frequency waves and they are used in many devices such as remote control items, cell phones, wireless devices, etc. The next wave that we have is a microwave. Now these microwaves are longer than the radio waves and shorter than infrared or visible light waves. They are mainly used for communication, medicine and consumer use. That is, more often I can say microwave ovens. The next type of wave that is involved is an infrared wave. Now, these infrared waves are invisible electromagnetic waves that are detected as heat. They can be detected with special devices such as night goggles. They have higher energy than microwaves but lower than visible light. The next wave that we have is visible light. Now, the portion of electromagnetic spectrum that human eyes can detect is the visible light. So, visible light basically consists of different colors, which are red, orange, yellow, green, blue, indigo, violet, where red has the lowest frequency and violet color has the highest frequency. Now, the next wave that is involved is an ultraviolet wave. These ultraviolet waves have higher energy than light waves. They can cause skin cancer and blindness in humans. The next type of waves that we have are X-rays. Now, talking about X-rays, they are high energy waves. They are mainly used in medicine, industry, and astronomy. These X-rays are also called to produce cancer. The next waves that we have is gamma rays. Gamma rays has the highest energy as compared to all the other waves, and they are blocked from Earth's surface by atmosphere. So these were the different waves which are involved in an electromagnetic spectrum, and each of the waves have their own different properties. So that's all about the electromagnetic spectrum. The next topic that we have is an inverse square law. The inverse square law states that the intensity of illumination produced by a point source varies inversely as the square of the distance from the source. So basically, in simple words, it can be said that as the distance increases, the intensity keeps on decreasing. In a mathematical form, it can be denoted as E is equal to I upon D square, where E is the energy, I is the intensity, and D is the distance. So as you can see here, we have a source which is emitting some kind of energy, and as the different distance increases, the intensity keeps on decreasing. In the area 1, as you can see, the intensity is E upon 1 square. In the second area, in the next area, that is area equal to 4, we can see that the intensity is E upon 2 square. In the next area, we can see the intensity becomes E upon 3 square. So as you can see, as the radius keeps on increasing, the intensity keeps on decreasing as the denominator keeps on increasing. So it can be concluded that as radius increases, it will be inversely proportional to the square of the distance. For parallel surface, that is cone and pyramids, light spreads over a surface inversely proportional to the square of the source. So that's all about the inverse square law. Thank you.